In this video, we're going to be doing applications of linear equations that are going to involve addition and subtraction. It is impossible to solve every single word problem out there, but the goal of this video is hopefully to help you kind of realize how the phrases of different problems gives you an indication of how to set up that equation and to solve that equation, and hopefully it improves some of your critical thinking by looking at how the word problems relate to each other. Example 1, when the price of a computer was reduced by $124, the sale price was $1,250. What was the original price of the computer? So the step 1 is describe the above situation as a linear equation, using x or y as the variable to describe the unknown quantity. In this step, it's not wanting us to actually solve an equation, it's wanting us to create the equation. So I'm going to allow x to be the original price of the computer because that's what the question is asking. That's what we're wanting to solve. Next, I'm going to look at some of the wording in the problem. And if you notice, it says reduced. Reduce means subtraction. And so think about how you're going to get the sale price of something. You're going to take that original price and then you're going to subtract off that discount, which here it says it's reduced by 124. That's going to equal the sale price. That's going to give you the amount that you actually end up paying. So our equation is going to be that original price of the computer minus 124. That's the amount that it was reduced by. That's going to equal the sale price of $1,250. Next, step 2 is actually solving the equation. So to solve this equation, it's a minus 124. So in order to move that, we're going to add 124 to both sides. So x is going to equal $1,374. And that's going to be the original price of the computer. Example 2, an empty can weighs 15 ounces and a full can weighs 24 ounces. How much do the contents of the can weigh? So step 1 is the same as example 1. We're going to describe the above situation as a linear equation using x or y as the variable to describe the unknown quantity. So here we're just writing the equation. We're not actually solving in step 1. So I'm going to allow x to equal the weight of the contents of the can. So here you want to think about what's happening. The empty can plus the contents of the can is going to equal the weight of a full can. And so now we're just going to substitute in the numbers that we actually know. So we know the empty can weighs 15 and the full can weighs 24 ounces. So that's what we're going to substitute in. So our equation will be 15 plus x equals 24. Next, it's going to ask us to solve the equation. So then I need to move the 15. It's a positive 15. So I'm going to subtract 15 on both sides. That's going to give me x equal to 9 ounces because 24 minus 15 is equal to 9. Example 3. Two sides of a triangle measure 11.2 centimeters and 14.7 centimeters. If the perimeter is 30.2 centimeters, what is the length of the third side in centimeters? So step 1, describe the above situation as a linear equation using x or y as the variable to describe the unknown quantity. So I'm going to allow x to equal the length of the third side. The key word here in this problem is perimeter. Perimeter is the sum of all the sides. So that means we're going to take the first and the second side and the third side and we're going to add them to equal the total length, the perimeter, which is 30.2. So that's going to give me my equation of 11.2 plus 14.7 plus x equals 30.2. Now in step 2, it's actually wanting me to solve the equation. So in order to solve this equation, I'm going to simplify my left side of my equation. I have like terms, the 11.2 and the 14.7. That's going to give me 25.9. And then I'm going to have plus x equals 30.2. Since it's a positive 25.9, I need to subtract 25.9 on both sides. And then that's going to give me x is equal to 4.3 centimeters. So that'll be the length of the third side. And again, you can always go back through and you can check these. If you add 11.2 plus 14.7 plus 4.3, you will get 30.2, which is what we want as the perimeter. Example 4, the distance to the boat ramp less the distance Nita has already traveled is 11 miles. If the distance to the boat ramp is 45 miles, how many miles has Nita already traveled? So in step 1, we're going to describe the above situation as a linear equation, using x or y as the variable to describe the unknown quantity. So I'm going to allow x to equal the miles that Nita has already traveled, because that's what it's asking you. So then, looking at the problem, I see the word less. Less is going to mean subtraction. So if I take the distance to the boat ramp minus the distance already traveled is going to equal the remaining distance. And it gives us the distance to the boat ramp and it gives us the remaining distance. And so I'm going to substitute those numbers into the equation. And my equation will be 45 minus x equals 11. Then in step 2, I'm going to actually solve the equation. So I have 45 minus x equals 11. I have a positive 45, so that means I'm going to subtract 45 on both sides. When I do that, I'm going to bring down my negative x. That's going to equal negative 34. Now there's an invisible 1, negative 1 in front of that x. And so in order to solve this last step, I'm going to have to divide both sides by negative 1. And so that's going to be x is equal to 34 miles. And so if you think about it, the distance to the boat ramp is 45 miles minus the 34 miles. That gives us that first sentence, the distance to the boat ramp less the distance Nita's already traveled is 11 miles. 45 minus 34 is equal to 11 miles. So that gives us what we want.